Welcome to Lesson 7. This lesson explains what is a funnel plot and explains the various aspects in a funnel plot generated by the Revman 5.3 software of Cochrane when meta-analysis is performed. Please find examples related to dental research to help you understand better. So what is publication bias? Publication bias occurs when there is a systematic difference in the results of studies published and unpublished related to a research question. Either the unpublished studies were not published by the journals or the authors failed to make an attempt to publish their studies. Sometimes it could be the fault of the reviewer in not thoroughly doing a proper systematic search for all the eligible studies. Hence, publication bias indicates selection bias in the studies that have been selected. It has been reported that only about 50% of completed studies are published, primarily due to lack of time or interest on part of researchers or because of unimportant results and the journal rejection. Studies with significant or important results are favored by many journals, and so researchers have time to prepare manuscript on such research only. Negative studies are not published or sometimes even suppressed by sponsors if it affects their business interests. So, where can publication bias occur? Project dropped when preliminary analysis suggests results are negative. Authors do not submit negative studies. Results reported in small non-indexed journals. Editor rejects the manuscript. Reviewers reject the manuscript. Authors does not resubmit rejected manuscript. And journal delays publication of negative studies. Funnel plot is a scatter plot of values from the studies which can indicate the presence of publication bias if it is really present. This is the funnel plot generated in Revman 5.3. The x-axis is the effect estimate risk ratio RR for binary data. The y-axis is the standard error SC of the log of the risk estimate RR. This makes studies with more sample size on the top of the funnel and lesser sample size on the lower side. Can you see the clustering studies of studies in two layers? Further, the funnel is made by the 95% confidence interval of the RR. The overall pooled estimate is the median line. The small circles are the individual studies which are plotted. Just check now, you can make an arbitrary line dividing two groups of studies. The top group are studies with a large sample size. Two aspects to check in a funnel plot: whether studies are distributed on both sides of the overall effect. It indicates that all publications with positive or negative outcomes were selected for the meta-analysis and the meta-analysis is reliable. In this picture, it is not so evenly distributed. In this plot, the studies are sort of evenly distributed and can be interpreted that there is no publication bias. In this plot, however, the studies are heavily on the left side, indicating that there is possible unpublished studies with results favoring the right side group, but not present in the meta-analysis. So there is a strong possibility of publication bias. The next aspect is to check if the small studies are influencing the results of the meta-analysis. In this plot, we have arbitrarily divided studies into small and large studies based on the clustering. Here you can see that the large studies are evenly distributed while the smaller studies are concentrated to the left side. So it interprets that the right-sided small studies are not present, indicating a publication bias. If the pooled estimate favors the left side, then it should be checked as the smaller, less quality studies could have influenced the results. This is called as small study effects. In this example, we find the meta-analysis shows that the test is more effective and the smaller studies are clustered to the right side of the test. There is possibility that the smaller studies influence the results and the real value could be different. Here publication bias is present due to small studies being favoring the test side and the relative absence of the control side studies. So interpretation should be careful in this scenario. Publication bias, few final words. The funnel plot is a visual representation. There are statistical tests available to help assess the publication bias, like Eger test, wherein significance shows that there is a significant publication bias. Publication bias is not an exact science. Hence, there is a huge responsibility on the reviewer to state the accurate results. Well, we have come to the last lesson. Hope you could understand and start doing the meta-analysis. We learned on meta-analysis as an overview, what is binary and continuous data and their effect estimates, pooled estimates and their interpretation, heterogeneity and their importance, and the meta-analytic models to use. Then we learned on forest and funnel plot and how to interpret publication bias. Remain would be a good start. It is free and very user friendly. You can access their YouTube videos for how to do meta-analysis. My next course will be an hands-on and meta-analysis in Remain. Thank you and see you soon.